Welcome to this explainer. Listen, today we are opening up a literal 200-year-old cosmic cold case. We're going to dive deep into a mystery that completely baffled some of the brightest minds for centuries. And honestly, it challenges the absolute limits of human perception. So let's piece together this grand puzzle, shall we? Okay, let's dive into this. Next time you step outside, just look up at the night sky. It's mostly dark, right? You see a few little specks of light set against a whole lot of black. But here's the central question we're tackling today. If the universe is infinite and it's packed with stars, shouldn't the whole sky just be blazing with light? I mean, why doesn't our seemingly endless universe produce a blindingly bright sky? Section 1. The cosmic crime scene. To really get how baffling this is, we've got to set the stage. We're traveling all the way back to the year 1823 to meet an astronomer named Heinrich Olbers. Now, Olbers treated the night sky like an actual crime scene, a place where the physical evidence right in front of his eyes made absolutely zero logical sense. He pointed out what we now call Olbers' paradox. He realized like if the universe was infinite and full of stars everywhere, then no matter where you looked, your line of sight should eventually hit a star. Basically, the night sky should be this blinding, continuous glow, literally as bright as the sun. But obviously, it isn't. It's black. And I'm telling you, for a century, this paradox was a massive embarrassment for astronomers. And this brilliantly illustrates exactly what he meant. Think of it like standing in the middle of a forest that just goes on forever. No matter which way you turn your head, your view is eventually going to be blocked by a tree trunk, right? Well, in the cosmic version of this infinite forest, every single point in the sky should hit a star, lighting the whole thing up. The fact that it doesn't, that meant something was deeply, fundamentally wrong with our understanding of the cosmos. The timeline of this mystery spans a whopping 200 years. Like I said, the question was posed in 1823, but getting the answer, that required a total revolution in how we see everything. Even with our absolute best telescopes in the 1990s, we couldn't fully close the case. It wasn't until a massive, game-changing breakthrough in 2016 that we finally understood the truth. So let's walk through the evidence together, step by step. Section 2. Suspect 1. Cosmic dust. Early astronomers obviously tried to solve this, and their very first suspect was exactly that, giant, thick clouds of dust floating in space. They thought it acted like a heavy fog rolling in over a city, just blocking the starlight. But that theory had a fatal flaw. The problem boils down to simple thermodynamics. Look, anything that absorbs that much light and energy from an infinite number of stars is going to heat up. Eventually, that dust would start glowing itself. The sky would still be radiating immense energy, it would just be doing it in infrared light. Now, that's a color our eyes can't naturally see, but it would be a glow that was everywhere. So the dust theory? Totally a dead end. Section 3. Clue 1. The Big Bang. The mystery only got deeper. The cosmic crime scene was completely clean. But the first real breakthrough didn't actually come from studying the darkness. It came from studying the light itself. 13.8 billion years. See, the Big Bang Theory showed us that the universe isn't eternal. It had a beginning. And because light travels at a set finite speed, we can only see things if their light has had enough time to actually reach us since the universe began. Light from a galaxy more than 13.8 billion light years away simply hasn't arrived here yet. This creates a sort of cosmic horizon, like a bubble around us. So suddenly that infinite forest of stars we talked about, yeah, it doesn't apply anymore. Section 4. Clue 2. Expanding space. Now, figuring out the universe has a finite age was a huge step. But the darkness was hiding a second, even weirder clue. Discovered by Edwin Hubble, we learned that the fabric of space itself is actually expanding. Space is stretching, and it's carrying distant galaxies away from us. So the crucial point is what happens to their light. As these galaxies race away, the light they send out gets stretched right along with the fabric of space. We call this redshift. The light actually stretches out so far that it shifts completely out of the visible spectrum and into invisible infrared, microwaves, and radio waves. The sky isn't empty at all. It's practically a graveyard of stretched invisible light. If redshift sounds just a bit too abstract, think about the Doppler effect right here on Earth. You know when an ambulance drives past you, its siren sounds lower pitched as it moves away? That's because the sound waves are stretching out. Well, retreating galaxies do the exact same thing to light waves. The visual pitch lowers until the galaxy disappears entirely from our view. Section 5. The 2 trillion galaxy twist. Now, having a cosmic horizon and an expanding universe explained a whole lot. But astronomers realized it still wasn't quite enough to completely close the case. We needed a proper head count of the universe. In 2016, a team led by Christopher Consolis decided to look deeper than anyone ever had before. They took 20 years of flat Hubble Space Telescope data and essentially turned it into a 3D time machine. And what they discovered was that the early universe was like a packed party. It was filled with tiny, faint cosmic wallflowers, these ancient galaxies just crammed together that later merged to form the much bigger galaxies we see today. Now, what's really interesting about this slide is that the sheer scale of our previous ignorance is just staggering. For decades, based on the absolute best 1990s Hubble estimates, we thought there were maybe 100 to 200 billion galaxies out there. But that early estimate was horrifyingly wrong. Consolis's team came up with a jaw-dropping new headcount. 2 trillion. Trillion with a T. That is 2,000 billion galaxies in our observable universe. And remember, that is just the baseline. Some recent estimates push it even higher. Section 6, a teeming hidden cosmos. So we have this staggering new number, and it completely changes our understanding of the universe. But it brings up a really obvious question, right? If there are 2 trillion galaxies out there, why on Earth can't we see them? Well, the answer is a mind-bending reality. A shocking 90% of the cosmos is completely invisible to us. We live in a universe 10 times more crowded and 10 times more hidden than we ever realized. The vast majority of these galaxies are just too small, too faint, or too radically redshifted for even the Hubble telescope to have seen. To really wrap your head around this, take a second right now and visualize holding a tiny pinhead out at arm's length. Got it? Now imagine holding it up against the blackest, emptiest patch of the night sky you can find. In that tiny sliver of space covered by the pinhead, Hubble found over 10,000 galaxies. Every single patch of empty sky is actually teeming with cosmic structures. You just aren't equipped to see them. Section 7, closing the case. With all of this incredible modern data, we can finally return to Heinrich Olbers standing in the dark back in 1823. The night sky is dark for a trifecta of brain-breaking reasons. First up, the cosmic horizon. The universe is only 13.8 billion years old, so light from beyond that edge literally hasn't had time to reach us yet. Second, cosmic expansion. The space between us and distant galaxies is stretching, pulling their light into invisible, low-energy wavelengths. And third, the hidden population. 90% of the 2 trillion galaxies out there are simply too faint and too ancient to pierce the veil. The empty night sky isn't a sign of loneliness. It's a map of cosmic history. Honestly, the darkness of the night sky is actually the ultimate proof of how spectacular our universe is. It is the shadow cast by 2 trillion hidden galaxies. We aren't staring into a lonely, empty void. We are looking out from inside a glittering, expanding snow globe filled with trillions of ghost galaxies playing a game of cosmic hide-and-seek, which leaves us with a thrilling question to wrap up on. If 90% of the universe is hidden right in front of our eyes, what else is out there in the dark, just waiting to be discovered?